to understand what the terminology is. There are some specific. Oh, okay. There are some specific terms that you need to know the definitions for. They are in this section, and you will go find the definitions yourselves. But these are the ones that I want you to know. There are more than this, but these are the specific ones I want you to know. So write these down so you make sure you get the ones that you need. On the test, it will be a definition section.
Are you like check my notes and see if we have?
No.
These are throughout the chapter, just 9.1.
9.1.
So we'll have more?
Yeah.
Okay.
As we go on. But the kind of throughout the chapter is more using these things to find measures.
Mm-hmm.
Along with all of our right triangle stuff that we learned last chapter. It's nifty. Radius, a chord, a secant, diameter, tangent, point of tangency, concentric, what does that mean? Inscribed and circumscribed. And I'm going to have actual picture illustrations of each and every one of these things that I'm about to show you. But you're going to need to know the word definitions. Yes. All right, are y'all ready? Okay, first thing we need to know is the way we name a circle. We talked about how we name segments, how we name lines, how we name triangles, and on and on and on. You name a circle by the center. If it is point O, you call this circle O. So if you have several circles on a page and they're asking you for information about circle O, you know which one to look at. So it's named by its center. In circle O, a radius would be a line segment that goes from the center of the circle to the circle itself. Now, this is only one radius that's drawn. You need to know there are an unlimited number of radii in a circle, and they all have the same measure. Okay? A diameter joins 2 points on a circle and cuts straight through the middle. We should already all know that the relationship between a diameter and a radius is what? The radius is half of the diameter. Exactly. Now, a diameter is a chord. It's a special chord because it goes through the center of the circle. But the definition of a chord is simply a line segment joining 2 points on a circle. It can join any 2 points on a circle. It could join these 2 points right here. That's a chord. All right? As long as it joins 2 points on a circle. A secant is different from a chord because it's not a line segment, it's a line that's going through a circle. It continues. And so we need to know the difference there because if you're asked to name a secant and you put ST with simply a little bar on top, you've named a chord. Okay, you have to know how to correctly name lines and line segments.
Right, you put the arrows on top?
Yeah, you put the arrows. A tangent is a line or a line segment or a ray that connects to only 1 point of the circle. It's flat and it butts up right on the edge of the circle, touching only 1 point. And that point is called the point of tangency. All right, if you imagine a bullseye or a target, that would be an example of concentric circles. Concentric circles all have the same center, but they have different radii measures. So they're smaller and they get bigger, but they all share the same center. So if you think of dropping a pebble in the water, and you see the circles that ripple out from the pebble, Those are concentric circles. Those are natural, God-made concentric circles. And they're pretty.
Dear God.
We're also going to be dealing with spheres in this section. A sphere is like a what? A ball. Okay? All right. You can also have concentric spheres. If you would imagine different sized balls, one inside the other, where they're all like floating in space to where they all share the center. That's like a bubble in a bubble. Very good. Okay. All right. Now these pictures, if you look at them, they're polygons that are inside of circles. And there are two ways that they can be described. If you're talking about the polygon, if you name the polygon first, it's inside the circle, so you say that it is inscribed in the circle. The first picture is a triangle inscribed in a circle. The second picture is a pentagon inscribed in a circle. It's inside. The last one is a quadrilateral inscribed in a circle. Now, what makes it inscribed is that every vertex on the polygon has got to sit on the circle itself. If one vertex, say right here in this quadrilateral, if those two lines did not meet there but instead came here, 3 of the 4 vertices are touching the circle. One of them is not. We could not say that it's inscribed in the circle. Okay? Another way to say these same 3 things is if you name the circle first. For the first one, you would say a circle is circumscribed around a triangle. A circle is circumscribed around a pentagon. Circumscribed around a quadrilateral. Okay? So it's not 2 different things, it's 2 different ways of saying the same thing. Does that make sense?
The first one would be like circumscribed about a triangle.
Right. Exactly. Oops. I pressed the wrong button. Okay, in this picture, this is actually from the classroom exercises in your book. Okay, this is the picture from your book. You have circle O, which means O is the center. And you have these various points on the circle. Name 3 radii of circle O. Raise your hand. Don't just blurt it out. Meredith, what's one?
OT.
OT. But we would want to say segment OT. And if you were going to write that on your paper, it's a single line segment over OT. What's another radii of this circle? Haley? OR is another one. Segment OR. What's another one? Lauren?
OL.
OL. Is there another one that's not drawn?
Yeah.
SO.
SO is another radii. As long as you join the center of the circle to a point on the circle, that's a radius. There are many more radii up here. I could put a point right here. And if I drew a line from O to that point, that's another one. Okay? So you need to be aware when we're working with these images that sometimes they may be asking you questions about something that's not even drawn on the picture, but it still exists. Okay? Name a diameter.
Segment or L.
Segment or L. And if you were going to write the segment, it does not have arrows. It's simply a straight line over the R and the L. There aren't any other points that we can connect and create a diameter with the points that are shown. I'm not sure if H is exactly where it needs to be. It looks a little down.
I have a quick question.
Okay.
Whenever you're naming the radius, do you have to put the O first, like the name of the circle?
It's customary to put the center first, but I won't be super